All right, so this video we're going to talk about diagonals and then a pair of opposite sides in parallelograms. So we're going to start out with some theorems. Converse to the diagonals of a parallelogram theorem. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here's a picture of what that would look like. So if AX is congruent to CX, and BX is congruent to DX, so those diagonals bisected each other, then ABCD is a parallelogram. Another theorem we have is the one set of parallel and congruent sides of a quadrilateral. So if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So if you notice, here's a quadrilateral, and you know that you can focus on just one set of opposite sides. So if BC is congruent to AD and also parallel to AD, with those arrows for parallel, if both of those things are true for one pair of opposite sides, then ABCD is a parallelogram. All right, so let's take a look at an example. We're going to investigate the diagonals to confirm a parallelogram. All right, if AX equals this, CX equals this, BX equals this, and XD equals this, what values for M and P is ABCD a parallelogram? So if we take a look at, they gave us 4 segments. Where are those 4 segments in our quadrilateral here? Here's AX, here is CX, here is BX, and here is DX. So if this is a parallelogram, then those diagonals would bisect each other. So ABCD is a parallelogram if diagonals bisect each other. So let's work with diagonals bisecting each other. So if the diagonals bisect each other, that means that AX would be congruent to CX. So we're going to set that up. AX congruent to CX. They told us that AX is 6M plus 4. Let's set that equal to CX, which is 9M minus 5. Solving for M, I'm going to subtract 6M from both sides, get the M's together first. 4 equals 3M minus 5. We can add 5 to both sides, and we have 9 equals 3M. Divide both sides by 3, and you get M equals 3. All right. If the diagonals are bisecting each other, that also means that BX would be congruent to DX. So let's figure out what value would make this true. So BX, they told us, was 5P minus 7. Set that equal to DX, or XD, I think they said XD in the picture, same thing, is 2P plus 8. And then let's solve for P. So we will subtract 2P. Again, I usually add or subtract the smaller variable. It just leaves you with a positive variable to work with. So 3P minus 7 equals 8. Let's add 7 to both sides. So we have 3P equals 15. Divide both sides by 3, and we're getting P equal to 5. Now, if we were to plug those back in, we would get, I'll just tell you what we would get. AX would be 22, and CX would be 22, if we were to plug in a 3 for M. If you plug in a P for 5, that gives you 18 for BX and 18 for DX. So those diagonals are bisecting each other. So our concluding statement will be, if M equals 3 and P equals 5, then ABCD is a parallelogram. those are the values for M and P that would have the diagonals bisecting each other.